Okay, so the next kind of whole chapter is image transformations. Pretty basic things. You can do things like cropping. So you can draw a selection and go image crop, and then you end up with just that selection. So this is often what people do when they're making their figures. You know, you might crop right in and have like a little inset for some little region or something that's interesting. No matter what shape you do, it'll always expand your selection to be a bounding box. It's never going to crop into like a round window for you all of a sudden. And then the other thing you can do is to do like rotate. So sometimes for whatever reason, if you know you're going to have like a scale bar and you've got like another cell or something in this corner and you want to rotate it, so you've got white on black and things like that, that's just under image transform rotate. So sometimes you need to do it. There is some weird things that happen if you rotate it once and then rotate it again and again. And people have pointed out over the years on the forums, like if you do it 360 times, it doesn't actually go all the way around 360 times. So be careful, just rotate once. So there's a, I don't have a slide for it actually, but often what I'll do is go image duplicate because I'm probably going to stuff it up. And so rather than having to reopen the whole image or the frame or whatever, make a copy, try my thing. If it works, great. If it didn't work, oh well, close the window, duplicate again, carry on. So that's something to do. I'll talk about it a bit later, but you can save this overlay that you've drawn, so then you can have the same size cropping for your other images. We'll talk about that coming up. Another feature that isn't used as much, but I think it's really useful, is straighten. So in my haste to include this, I didn't have a picture of like a membrane. You can imagine that the river here is a membrane, but you can draw like a segmented line along it. This could be a neuron or an axon, or it could be a cell membrane. Use your imagination. But if you go edit, selection, straighten, and thicken the line, you get it all straight. So if you wanted to quickly measure the thickness of the green vegetation around the river, or that could be e-coherent on a membrane or something, way easier if it's all in a line. Or if you want to show that, you know, something happened at the end of the axon and it got really bright or something, and you wanted to line up 10 treatments, you can do that. Quite nice. So yeah, to do this, make a line or rectangle selection. Usually line's a bit more easier because you're probably going to have a curved thing that you're trying to straighten. And then adjust its thickness, double click on the line tool and make it 100 pixels wide and straighten it. And you get that. Quite useful. Another thing is to reslice your data. So here I've got 2 cells, and who knows, maybe one of my treatments made the cells get really tall. So I wanted to show that really easily. You just draw a line and hit reslice and you get like a cut through and you see the XZ or YZ axis, and then you can compare things, and it's quite useful. There's also orthogonal views. So here I've got a cell and I'm going to go image stacks, orthogonal views. And now I have that reslice both in X and Y. As are on the X-axis and Y-axis. So I get these 2 windows and they're linked by these lines. And so it's really hard to show 3D in a 2D picture or figure on your paper. So this can be quite useful to show something around an endosome, or if you want to show 3 things at the same spot, you can do that. So this is quite useful. You can make a montage. So if you're trying to show, if you've got, you know, a time series, so who's gone through and gone time point 1, copy, paste, time point 2, copy, paste. Fiji has a tool that does that for you automatically, whether it's T or Z, and you can tell it how many columns, how many rows, what scales to shrink it down to. If you want a border, what you want to increment, so you might want every 5th one. So that'll do it all automatically for you, making your window nice and easy. Z projections, this is one that pretty much everyone should be familiar with, or probably will become familiar with. So if you take 3D data and you just want to flatten it down, that's a Z projection because you're projecting over the Z axis. There's different types. So if you're going to do quantification, you should probably do it on sums, not max, because unless your question is what's the brightest pixel that was in my whole cell or fish or whatever, if you sum it all together. But if you do sum it all together, make sure you have the same number of slices. Don't sum 5 slices and then compare it to an image of 10 slices that you sum. You can do averages, maximum, minimum, standard deviation. There's a whole bunch. Usually, if you just want to visualize maximums, what you're going to use for fluorescence. If you've got a bright field Z-stack, you want to do a minimum because bright field is dark objects on a light background. And so you want to keep all the dark objects that's blocking the light, right? That's what you, so yeah, you might want to try that as a method if you're inverting lookup tables and doing funky stuff like that. Okay, so by now you might have a bunch of windows open. If you hit enter, it brings up this window to the top. Really useful, especially if you're on your Mac where the top, you've got to have that window selected to get all the menus at the top. So just hit the return or enter key and it brings that to the front. All right, exercise 4. We're going to open some data, Z-stack, we're going to do a Z projection. Have a go at some of the ones that you might not have used, see what it does, and then save them out and